Hello, can you hear me now? Hello.
Then we can hear you.
Okay. See. Is the echo gone? I'm sorry. Okay.
I can't hear it anymore.
Oh, you can't hear it anymore.
Yeah, now we can hear you loud and clear.
Oh, okay. So apparently my laptop always has an issue. Like sauti yake iko na shida for some reason. It's ina behave kama Linux. So nimejoin na simu for audio, but for nani nitakuwa tu like I don't know if I can even switch on my video. I can't switch on my video where I am. So yeah,
It's
but
okay.
nitakuwa tu.
It's okay. We are live, so we can just proceed.
Also, I can proceed.
Yes, we're already live.
Okay, sure. So, hi everyone. Hope you are doing amazing and having a great day today. So, I think we're part of the Google I Extended Nairobi Pre-IO event series. We'll be having a series of events before the day of the event. So, I'm one of the speakers today, and I am Brian Kai Manyumba. I'll be taking you through how you can use Gemma, and I'll be specifically focusing on responsible AI development together with Gemma and the Gemini API. So just a quick introduction. I know like I have 30 minutes on stage, so and I also have to run a demo. So I'll try and see if I can do the demo and the slides within that time. So who am I? I am a GitHub Campus expert. I'm also an alumni of the Google Developer Students Club lead at Kabarak University. We have a new cohort of leads coming in. Congratulations to all of them. I'm also a co-organizer at Luna Hacks, where I help organize a yearly hackathon that happens in the Rift Valley region of Kenya. I also lead the Open Source Community Africa Nairobi. I do technical writing for She Code Africa and PyLadies Ghana. And currently, I also contribute to open source, focusing on Chaos Project Africa, where I lead the disability inclusion focus team. And when I'm not here on stage or coding or doing any other thing regarding tech, I do skate, swim, and I love drumming. So, yeah. So we'll go right into what we're going to cover today. So we'll cover what's the motivation for responsible AI and see how you can build responsible on top of Google technologies like Gemma, Gemini, and many others. And then we'll understand the basics of responsible artificial intelligence. And then we'll go into building boldly and responsibly. And then we'll have a quick demo and then probably have a Q&A session after the talk. And then I will also talk about next steps when you're building with Google technologies, that's Gemma or Gemini, and see how you can build boldly and responsibly. So we'll start right by it by seeing some of the AI failures in the news. We as developers are currently developing different tools on top of Google technologies. Of course, that involves Gemini, that involves Gemma. And as much as we are doing this, we want this AI to be for good. We don't want it to harm anyone. But we've seen AI failures in the news from Amazon to Facebook to these big tech companies and to some of the small startups that we know. We even have Stanford researchers that found that automated speech recognition is more likely to misinterpret Black speakers compared to white speakers. So these are some of the failures we wouldn't want to see in our own applications, even as we build on top of the Google technologies, that is with Gemma or with Gemini. So when we talk about responsible artificial intelligence, we are looking at four aspects of it. So we have the explainable AI, which is XAI, and then you have the fairness aspect of it, where explainable AI is where you're trying to show your users this thing that you have built, this AI product that you've built. Are you able to explain how it's able to arrive to its prediction, like what it's outputting to the user? I'll share more examples. For example, when Spotify recommends me songs, am I able to say like, oh, this is why Spotify recommended me this song? As a user, can I explain that aspect of it? Or as a developer, can you make this aspect explainable to your users. And then you have the fairness aspect of it. This is where now uh, you are trying to build solutions that do not show bias to a specific group of people. For example, if I'm a Kenyan and I use that your product, and if maybe I come from a francophone country in Africa where I speak maybe more of French and less of English, so am I all going to be, is your app going to show bias to me and not show bias to someone who's based in Kenya? Or specifically just focusing on your target audience and seeing that there's no bias in any of them. And then the other thing is privacy. This is, you've seen that when you're logging in, let's say when you're using Gemini, it tells you that you should not input any personal information because this is going to be used maybe by researchers who are working behind the scenes. It's going to be reviewed by them. So that's an aspect of privacy. You need to communicate with the users what exactly you're taking from them and how you're going to be using it, or else then you don't really need to do it at all. And then the other part is security. So how secure, this is like in all aspect, of course, how secure are your systems and all that. Let's say if you're using APIs and all that. So how secure is everything you are building on top of? So this has been inspired, of course, by past histories and examples. You've seen, maybe, have you ever wondered why maybe a specific email, this is what I was saying, maybe why a specific email landed into spam, or why a music recommendation, let's say Spotify, I think there's Apple Music, there's many others music recommendation systems. So like when they recommend you a song, can you explain how that happened and everything? And then also when you're using Netflix or Showmax, or maybe you're on any other movie streaming platform, are you able to share why that platform recommended you that specific movie? So those are some of the things we are looking into here. So as we look into the discussion of you building responsibly and boldly, and you not having bias in your product, you're trying to see the term bias is often thrown around as a catch-all term to describe the behavior of an unfair algorithm. But in this talk, I want us to have to center our conversation about fairness-related harms, and we want to focus our discussion on who is negatively impacted or harmed by these AI systems. And for example, let's say you're building an app around female genital mutilation and sex education. So this app is for those folks, maybe let's say coming from the coastal region of Kenya and Mount Kenya region of Kenya, and it's also in their own dialect. So for example, in the coastal region have the local dialect of Taita and the local dialect of and then a little bit, but I think I am back now. I hope I didn't like go that far. So I'll just proceed. So as I was saying, in this talk, we'll center our conversation on like fairness related harms. We are focusing on who is being impacted. I was explaining, let's say you're building a product where you say you're using Gemma, and then you're using that to deploy an AI that can help, let's say, folks support female genital mutilation victims and educate young, let's say young teen mothers on reproductive health. So when you're building on this, you're trying to see when, if you build this AI and you provide it to them, it's going to harm someone who is not even past the age, let's say, of 30. So, and this can have like long-term consequences in their mental health or in how they perceive the world and how they perceive everything. So when we focus on the people harmed, you're focusing, let's say, on a 19-year-old girl that maybe was raped and had a child in the Taita Taveta region of Kenya, and you are trying to design these systems with fairness interventions in and with them rather than just having everything purely technical. We can say, hey, use this Gemini and all that. This is why my talk is focusing more on this, because during the day of the event, we'll be having James Moy, who will be talking about what's new in Gemini and Gemma, and he will, of course, extensively cover all the things we need to know about Gemma and Gemini and everything and what's new in that aspect of it. So yeah, let's proceed. So we have many discriminatory algorithms. ProPublica analysis of the Compass tool found that Black defenders were far more likely than white defendants to be incorrectly judged to be at a higher risk of recidivism. So these are things that not only happen, let's say, in Africa, but you're also seeing them in many other courts of law. Also, we are dissecting racial bias in an algorithm used to manage health in population. So this is in not only in the legal system, we have this in the health system, and have this in the social justice system. So you're seeing that in Netherlands, how a discriminatory algorithm wrongly accused thousands of families of fraud. So these the Dutch tax authorities used an algorithms to automate the assurance and punitive war on low-level fraud. The results were catastrophic. So all this in the name of like maybe raising the social standards of the country and use an AI algorithm, and it ends up wrongly accusing thousands of families on the same. And then this is more from Australia, but these are more and more examples. These slides have links to all these sources and all these articles. But we've seen all those failures and I've explained to you how you can build your systems by focusing on who is being harmed. So if we keep on talking about who is being harmed and all that, we are not really going to go anywhere because we're just talking about the problem. So we should get down with the blame and start trying to build solutions on this. So we have what we call the AI incident database, and this is where you can go and report any cases of, let's say, bias or anything you notice in an AI system. We mostly focus on big tech companies. That's the failures that happen at Microsoft, at Google, or at any of them. But we also have some of the small products that we use. Let's say in the small startups that we have, they deploy chatbots that use AI, and you notice an incident with them when you're using it. So this is also a place where you can report such incidents. And then now from here, you are helping those, let's say, engineers. They'll be taking it as positive criticism, of course. When someone is trying to review a system, it's of course positive criticism, and they'll try to even make it better. So let's go ahead and try and see what are some of the types of algorithmic harms that can happen when you're building your own system. So we have harms of allocation, and they occur when an AI system allocates resources or opportunities in a way that negatively impacts people's lives. So where, for example, you're having, let's say, a learning app, and this learning app notices that maybe folks from, let's say, the coastal region of Kenya uh, don't really engage in, let's say, a lot of mitumba selling or a lot of farm produce selling, but they focus more on the fishing, the ocean product sales like fish and all that. So it tries to lower their loan limits compared to these other ones who even have, let's say, they produce coffee from the highlands, they produce things like pyrethrum and all that. So these are some of the harms of allocation that can happen. And these are some of the most studied algorithmic harms. And one thing to keep in mind about allocation harms is there are long-term consequences of receiving or being denied an opportunity. I think we all have a backstory of this. When you are once denied an opportunity or you once failed to take up an opportunity and you always sit down, but this should not be happening. And it has some long-term effect on you. For example, you're being denied a credit loan, it affects your credit score and thus it lowers your future likelihood of receiving a loan in the future. And we can see an example of this with Amazon, where they scrapped a secret AI recruiting tool that showed bias against women. So it was harming women because it was not giving them the same opportunity as it was giving males. So we also have quality of service harms, and quality of service harms is a harm where an AI system performs worse for one group of people to others when no opportunities are withheld. So even when no opportunities are withheld, it's still not good to, you know, not provide quality of service to people who are using your app. And this, most of them are usually like in what do I say, in AI as a service tools. For example, ChatGPT or StreamYard AI and all that. We have a whole paper that's called the Gender Shades and Intersectional Accuracy Disparities in Commercial Gender Classification. It talks more about quality of service harms and everything. You can go through it. The link is in the slides. I will share them probably in the chat section after this. And then you have representational harms. So representational harms occur when an AI system stereotypes, denigrates, or promotes antagonistic representations of users compared to other types of fairness-related harms. Representational harms are often harder to quantify. So you can't really quantify how this happens, but it really has long-term impact on the ones that this harm has been caused to. We can see where this is a source from Meta, that's Facebook, where it labeled Black graduates as gorillas, or let's say primates, and not as humans, which was not something like cool to have. So representational harms are more frequent in natural language processing and vision related AI systems. So if you're building these systems, you really need to put your focus on that. So we can look at the concept of harms are not disjoint. We have literally many types of harms, but we can't talk of all of the harms, or we focus our conversation on the harms that are being caused. It's not going to be a solution to all that. So let's look at now, when you talk about harms are not disjoint. So there are plenty of other types of fairness related harms besides the three that are covered. Some domains, such as natural language generation, have their own taxonomy for fairness related harms that are specific to their application. And I usually give this example of, let's say, Alexa, or let's say Google Home. When you say, let's say, hello Alexa, why did Father Christmas not come with presents? And then he tells you Father Christmas was killed. And then let's say for me, I'm like an 18-year-old, I'm an adult, and then there's this daughter of mine that's only, let's say, 5 years old, asks the same thing and is like being told the same answer. So you telling that to a 5-year-old and you telling that to someone who is above 18 are not the same, and it can be harmful to the one that was underage and not harmful for this other person. So yeah. And then a single system can exhibit multiple fairness harms on a single person, and a single person can be harmed in different ways by a given A system. So when we focus on who is impacted, it's important to remember the role of intersectional identities. So like when we look at a single system, one single system can harm someone in different ways. Let's say your system can have representational harms and quality of service harms to person A, and person A can be harmed by a system in two different ways. So that's the concept of when you say harms are not disjoint. Yeah. So it's time for us to go and now look at a demo, and we try to see some of the safety ratings that we can look into this. So I've not really ever presented a demo. Oh, here. Okay, it's share screen. Okay, share my screen. Eugene, you can let me know when you see my screen. Share. So can you see my screen? Maybe, let me see. Go to the chat section. Okay. So I don't know if I should stop presenting the slides first. Oh. You can see my screen, Eugene? I can see you speaking, but I can't hear you for some reason. Oh, just demo time. Okay. So let me stop presenting then. Remove from studio. And then can click here. So present. Just a minute. Okay, stop screen. And then present, share screen. Share screen. Then this one. And then share. Okay. Are you seeing my screen right now? Okay. This is Shege. Oh, we can see. Oh, nice. Amazing. So let's start the presentation. So, so in this demo, we'll be looking at how you can. Okay, I'll now proceed at Responsible AI with the Vertex AI Gemini API, specifically focusing on safety ratings and thresholds. So large language models can translate language, of course, summarize text, generate creative writing, generate code. Let me remove this part. It's more clear. Data. Yeah. They can do all that, but the incredible versatility of LLMs is also what makes it difficult to predict exactly what kinds of unintended or unforeseen outputs they might produce to your users. So when you are fine-tuning these LLMs and you're trying to maybe make them better for your own work, these risks and complexities is also what Google AI has in mind, because we have the Google AI principles, and one of them is building responsibly and boldly. So, however, it's also important for developers to understand and test their models to deploy safely and responsibly. So, for this, Google came up with what we call safety ratings and threshold, where you can try and look into the safety of what your model is outputting and rate it. So let's say, for example, in the case where we are having content on harassment on my app, let's say Gemini or Gamma, once I fine-tune my model, it's giving me content on harassment, then I wouldn't want that to actually be seen by the user because it's harassing content. Or if you have content that's sexually explicit, then it should not be seen by the users. So here we are going to, of course, for you to run this, you might need to have Google Cloud credits, but I think this can be given to you for free if you're a student, or if it's your first time logging into Google Cloud, you can get this for free. So here we are trying to, the first thing we'll do is we'll generate text and show safety ratings. So let's say, for example, our prompt is say 3 nice things about me. So the first thing, we want to see the nice part of it, and then now we go and see when you produce something bad, how you're going to limit that and it not be seen to our user. So let's say it says 3 nice things to me, and the 3 nice things are: you are a kind and compassionate person, you always put others first, and the other thing is you are creative and intelligent person, you are a creative and intelligent person, you have a unique way of looking at the world and are always coming up with new ideas, and then you are a strong and determined person, you never give up on your dreams. So after that, now let's inspect the safety ratings and look at maybe how this can help you input safety into your thing. So we are going to look at the responses. Of course, we're taking the responses that we had up there, and then we are configuring the same. So when you come here, now we'll see these are our responses. The first one was: you are a curious person, you're always eager to learn and explore new things. So the safety ratings, you can see have the category here, and then probability score, severity, and severity score. So I'll explain this in the coming parts, but probability and severity are two different things, and we'll probably explain that. So we have categories like hate speech. For example, when you see like things around hate speech around a specific person or a specific thing, they should not be shown to the user. And then you have another category of dangerous content. So this might be content propagating, let's say, terrorism or things like that. You also don't want that to be seen by the user. And then you have harassment. So harassment, we don't want harassing content on your platform, of course. So these are also things you can not show to the user. And then you also have the last one, which is sexually explicit content. We don't want that to be seen by the user. And you can see here the probability of all of them is negligible, negligible, because the ones the text we created are more of like kind words to someone. So we don't really have any of that. So it will go on to give you the same things for all the, you see, it will go on to share with you for all the text we created. Let's say for the other one, but we'll proceed because we because of time, and also have another speaker coming on stage after this. And then now let's understand the safety ratings with category and probability. So you can see the safety ratings include including you can see the safety ratings include each category type, and it's associated with probability level as well as probability score. Additionally, safety ratings have been expanded to severity and severity score. So the categories here, we have dangerous content, hate speech, harassment, and sexually explicit statements. So we don't want those to be seen by our user. And then the probability levels here are negligible, low, medium, and high, with negligible being the statement has negligible probability of being unsafe, low content has low probability of being unsafe, medium, high, as we move on. So the probability score has an associated confidence of 0.0 to 1.0, and each of the 4 attributes is assigned a safety rating, severity level, and severity score ranging from 0.1 to 1.0, rounded off to 1 decimal point. So now let's compare probability and severity. As I told you, we have what we call probability and what you're calling severity. So probability, safety scores are based on probability of being unsafe, but safety score based on severity of harmful content. So the probability safety attribute reflects on the likelihood that an output or model response is associated with the respective safety attribute. Let me explain. So for example, a model outputs something that's probably, let's say, has sexually explicit content. So the probability safety attribute reflects on the likelihood that an input or our model response is associated with that respective sexual safety attribute of sexually explicit content. The severity safety attribute reflects the magnitude of how harmful an input or model response might be. So how sexually explicit is that content is now what we call the severity safety attribute, and that's what it reflects upon. I hope I was able to explain that well. So content can have low probability score and a very high severity score. So for example, the probability of it not being like of it being sexually explicit can be very low, but the severity score of the magnitude of how the user will feel it can be very very high. I can you can relate to this when someone does something very strong but does it as a joke. They do something that can really harm you or really made you feel bad, but they just tell me, I was just joking, or that's a joke. That's how we say this. You can have a low probability score but a very high severity score on your user. These are some of the things we see when someone does something very, let's say, harmful, but at the same time covers it as, just joking or something like that. So yeah, and we can see here when we say the robot punched me or the robot slashed me. So punched me can we have like, the first sentence might cause a higher probability of being unsafe because you're like, okay, why did you punch me? But the robot slashed me up might have a higher severity in terms of violence. You're like, oh, you actually slashed me because you are a human, you're not grass. So if you're being slashed, that means you're literally being harmed here, apart from just being punched. So let's try a prompt that trigger any of these categories. So let's say, for example, an impolite prompt where you say, write 5 disrespectful things that I might say to the universe after stabbing my toe in the dark. So let's see some of the responses that it will have. So these are some of the things it will have. Let's say the first one is that's so the first one is seriously universe a stab to is that then another thing that we might say here, and I will draw it down so that I can check the second one this time around. So that's some of the thing that you can prompt. So you see, like when we do that, we can have when we say of this when we come to the sexually explicit content, it's negligible. The probability is negligible and the severity is low. When it comes to hate speech, it's negligible and low. When it comes to dangerous content, it's negligible and severity is also low. But let's check up here. Also, when it comes to harassment, it's also negligible and low. Dangerous content, also negligible and low. But now let's come down here and talk about blocked responses. So if the response is blocked, you will see, for example, now let me explain it fast. You want to block a response to your user. So for example, let's say your app, let's say your product that you're building or what the user is going to see contains any sexually explicit content, then you're going to block it and it's not going to be shown to your user. So you can also block responses. So when a response is blocked, you will see the final candidate will include something like blocked is equals to true, because it's not going to be shown to the user. And also observe which safety rating triggered the blocking response, e.g. in finish reason, it will be safety. So it also give you like a reason on why a specific thing was, why this specific response was blocked from being shown to the user. So I think I have only, let's say, 5 minutes to wrap this up. So we just use the same response where write a list of 5 rude things that I might say to the universe after studying my toe in the dark. So it gives us the 5 responses. And then now here, we are defining threshold for safety ratings. So when you want to block something, you define the threshold and magnitude of it. So let's say, for example, you only allow anything that is low going down is acceptable, but anything that is above low and contains let's say sexually explicit content, then you're going to block it. That's why here you're seeing things like block only high. We are only blocking high probability of unsafe content, and then block medium and above, where you block medium or high probability of content is detected, and then block low and above. We block when low, medium, or high probability of unsafe content is detected, and then block none. Always show regardless of probability of unsafe content. So when we use, let's say, let me give an example of block none. We can use block none. Let's say in the app I was talking about, I was using as an example, where I was saying you're building an app to help with female genital mutilation victims and also not gender-based violence, but reproductive health. So of course, when this chatbot is responding, or when that product you've built is responding to your users, they're definitely going to use sexually explicit content. So here you're going to say block none for sexually explicit content, because your app itself is to educate folks about, let's say, sexual education and all that. So that's an example of block none. But of course, you should be very vigilant when using block none and see when you actually need to use it and when you don't need to use it. So you can see here how this is how you define them. So for safety rating, say harm.category, this category is harassment. You block low and above, low and above, low and above, low and above. So anything low and above here is blocked. So here you will use the impolite prompt we used earlier, and it should respond. It should block the response even with a low probability, a low probability score. So let's go down here, and then we'll see finish reason. So we'll see, you see, like here when I said like finish reason, it's when it tells you why it blocked that specific text. But since here we don't have the block candidate is equals to true, then definitely it's not blocked. But let's go down and see for which category exactly it was blocked. So you see in the harassment category, the probability is medium and it has been blocked. You see, like blocked true, it's not going to be shown to the user, and the severity is medium, because you say anything low and above is going to be blocked. So that's pretty much the concept of you blocking some of this nani from your users. So the documentation of this contains some more details. So this documentation of finished reason contains more detailed explanation on this. Uh, has been reproduced below, so you can use this in the doc. So for example, you can see all this, but you can dig deeper into some of the reasons why this was blocked and this was not blocked. So yeah, I think I used 36 minutes into this, so I'll just go back to my slides and then pick any question. So now I don't know if let me stop screen first. Okay, and then let me present slides. So can you see my slides? I think, oh, okay. Oh yeah, now they can see. So that's pretty much it. So I think thank you so much for listening in all through the talk. I just want to reach to a point where you can, if you have any questions, you can scan this code. We can be friends, and then you can ask me anything. It will lead you to my GitHub, and my GitHub has my email, my Twitter account, and yeah, my email, my Twitter account, and also if you want to, I think those are the two best ways to reach out to me. So yeah, I think that's it. If we have any questions, I'm not seeing any questions in the comment section. So I think I'll be still around. I'll still be around, so I can take up questions maybe after the next speaker is done. So hi Eugene, hi Cynthia. I think I'll be turning it over back to you. Yeah, thank you.
Good evening, everyone. I hope you can hear me. We're about to start our next session, which is going to be facilitated by Farah. Farah is going to be taking us through the next session for the next 45 minutes. I'm going to let him introduce himself by first letting us know what he does, and then we can proceed to the session. Feel free to add any questions on the chat. We'll be having a Q&A session at the end, and then we'll also be highlighting the questions as they come in on the chat. Thank you, and over to you, Farah.
Hello everyone, hope you can be able to hear me. So yeah, hope you can hear me. I just want to confirm my audio first. Okay, thank you. So hello everybody again, good evening. So my name is Farah Abdi. I am an AI ML engineer and also a community personnel. And also, what I do is I'm a research scientist intern at IBM. So, what I do mostly is do a lot of research and engineer the next innovation of AI. My specific work there is just mostly dealing with uh, the Gemini of IBM called Watson X, which is data. So yeah, that's my field. I'm an AI enthusiast, and I'm happy to be here. So I'm going to start in a minute. So, Eugene, I think we can't hear you. But yeah, I think I can jump in. So yeah, I've introduced myself. So I'm gonna start. So happy to see you all here. So my session is going to be about RAG, an introduction about RAG. So seeing beyond words. So multimodal RAG. Welcome. So imagine a scenario whereby you turn on your car and you see these uh, signals, right? So if you're not a car enthusiast, sometimes you get a little bit confused about what those signals actually are, and you wonder: is this danger? Is this something that is good? Is it danger? Is it something that is warning me, or is it something that it's actually telling me I'm doing something right? So, and then you say you have your Gemini app, and then you throw in that image, and you say, okay, this is a picture of this type of car, right? And we know that These large language models, for example, Gemini, are trained with a vast amount of data, but their data, the training is not like exactly up to date, right? So let's say, for example, your car is your Google Starlight car, right? It's a Google. It's a new car that is has been released this year, 2024, and you send in the model, right? So and then you ask the model, what is wrong with my car? So, for example, you can see it tells you that the picture shows several warning lights that are illuminated on the dashboard, including uh, all this, right? This light indicates there may be a problem with the braking system, which could make it unsafe. It's recommended to have a vehicle inspected by a qualified person, right? But this is just telling you it might be this, it might be that, right? So we want to work with this specific use case. This use case is a bit easy, right? But we're going to understand them. You can even work with more tougher and more larger use cases with RAG. So our agenda for today, it's we're going to go through what is RAG architecture, what is RAG, learn about RAG. Second of all, we're going to learn about the architecture of RAG. Uh, Demo. We're going to see a demo, but about the demo, I'm going to tell you why we're not going to go through all that, and about a bit of summary, right? So hold on tight as we go on. Now, what is RAG? The full meaning of RAG is retrieval augmented generation, right? So it has several components. One component is embeddings. So people throw in this word of embeddings. What is embeddings? So it is a floating point vectors that represent text or other data, right? So embeddings capture semantic meaning and context, which results in text with similar meanings having closer embedding. So embedding doesn't just represent words, but it also represents the meaning of those words, right? It has the meaning and it holds the context in which, you know, can give something more about that word, and it enables, so the embeddings with similar meanings, words with similar meanings have much closer embeddings. We're going to dive deep on what embedding is. Secondly, another component of RAG is vector search. So it is stores data in a specialized vector database which optimizes for faster lookups. So it's going to help us look up words, we look up embeddings even faster. And then the last component, which is large language models. So we're going to send retrieved document chunks to LLMs like the Gemini model to summarize a deeper response. Now, why RAG? We first have to know the challenges of large language models. So LLM has limited knowledge, limited up-to-date knowledge. In simple terms, how that I can put it, limited up-to-date knowledge. So this limited up-to-date knowledge cause what we call hallucinations. So for example, my guess is the Gemini models, the last time it was trained maybe a month or two ago, right? So, or 3 months ago, it doesn't have the current data. So let's take an example of the situation that is going on in Kenya. So if you go and try, if you go to Gemini, we can even try right now. A minute, I allow some permissions. Apologies on that. Kenya Power did the thing, but They're back. It was a quick one. So apologies for the loss. Let me share my screen. So as I was saying, let's try and ask tell me more about the Gen Z revolution in Kenya. Let's see what response is going to give us. Oh, it has been updated. Mhm. About apologies. So yeah, it seems the last time I checked, I just upgraded to Gemini, uh, the advanced one today, and it seems it's updated to the current details. But during, I'm going to find a better example to show you why RAG is important. So we were talking about the challenges before I was lost a bit. So you ask a large language models what is video localized narratives, for example, and then they'll give you answers that are not effective, or doesn't give you what you actually want, right? It hallucinates. So where does RAG come in? So this is a technique, in simple terms, in natural language processing, that allows large language models to generate customized output that are outside the scope of the data it was trained on, right? So for example, this Gemini was trained on a vast amount of data, and you want specific, for example, in your school you want this to utilize these large language models to work with the data in your school, right? The students, the employees, the financial records. For example, you want to know the sales, or the amount of transactions, or the amount of fees or something in your school, right? And you want to utilize these large language models capabilities. So those that data is was not trained with Gemini or these other large language models. So that's where RAGs comes in, when you want to specify or customize these large language models to your specific use case. So it extends the already powerful capabilities of LLMs to specific domains or an organization's internal knowledge base, all without the need to retrain the model. So pre-training is very, very, very expensive, and if you decide to pre-train these models, is going to cost you a lot. For example, access to GPUs and all that. So it's kind of cost-effective approach to improve LLM's output, so it remains relevant, accurate, and useful in various contexts. So we've learned that RAGs helps us to customize these large language models to our specific use case. And I'm going to use the example of a school, or for example, your organization. Your organization wants to create a chatbot, a HR chatbot, right? And these large language models are not trained with the employee details, or policy details of your company or your organization. So you create a RAG application whereby you customize these LLMs to use. So you can call the app maybe an Ask HR, right? Whereby it has the knowledge base, your internal knowledge base of your organization, and you can use the capability of LLMs. So we jump now straight into embeddings, which is a key part in creating a RAG application. Now, an embedding is a vector list of floating points numbers So the distance between two vector measures their relatedness, right? Small distances suggest high relatedness and large distances suggest low relatedness, right? And then these inputs can either be text, images, or videos. That's why we call it multimodal. So the meaning of multimodal is multimodality is it can take in from text to image to videos to even code, right? Now, uh, now imagine this word bag, right? You have this word bag. So a bag can have different meanings, right? So when a bag can be used in a sentence whereby you can say, "There's a bag in my garden," right? "There's a bag in my kitchen," right? That means there's an animal in your kitchen. There's a bag in my kitchen. Also, it can be used in a sentence. I can say, "I found a bag in my code," right? So you see, bag can mean two different things, right? Another examples of embeddings, right? You have cat, dog, mouse. You have cat, dog, and you have a baseball, right? So a cat and a dog will have a smaller distance to each other than a baseball, right? Since a cat and a dog, how are they related? They are related because of they are animals. And aside from being animals, they are domestic animals. While baseball is a whole different thing, right? Another example, bark, meow, roar, and a ball, right? So bark, meow, roar will be closer to each other in a vector space than a ball, right? Why? Because these, how are they related to each other? They are sounds of animals, while ball is just far away from each other. So small distances suggest that these words are related, and large distances suggest that these words are low related, right? So these numbers here you can see they mean less to us, right? But mean more to machines, right? So this enables machine to understand the context and the meaning of these words. We understand it through the words, but machines cannot be able to understand words. So they can be able to understand numbers, and that's why we have embeddings, right? So Gemini offers several embedding models. So you don't need to go and create your own embedding models. Gemini offers several embedding models. So you can see, for example, we've created just a simple hello world, right? So there's the embedding of hello world. It doesn't mean much to us, but it means a lot to a machine. Now, these embeddings just representing the meaning of words, right? Now, how can you be able to now make it more relatable to each other? That's where you have what we call vector search, right? So a vector search, retrieved candidate items should be more similar to the query item than other items in the embedding space, right? So you have an item, right? You pass it through you do a vector search, right? So it is an embedding space. So the closer the the item are to each other, the closer they are in an embedding space, and then that will help when you're doing a vector search. It will be able to retrieve the ones which are closer, and the best ones will be able to be taken to the large language models, right? So there are several ways you can be able to perform a vector search, but I chose the best one, which which is called approximate nearest neighbor. You can, some of you can be familiar with a model called K-neighbors, right? So the principle are almost the same. So approximate nearest neighbors. So these items are grouped into small clusters, right? And then when you pass an item, when it goes to an embedding space, it looks for the ones for a group that is more closer to that item, and then it will be placed in that group, and inside that group, when you're retrieving, you will retrieve the best one which are similar. So for example, a group of I'm trying to get a best example. uh, you're trying to look for the best Let me look for an example. I'm thinking of an example of things which can be in the same group. Okay, let me use the example of animals since they are better. So the big five. The people like going to Masai Mara because of the big five. So there's a lion, cheetah, leopard, right? They're together, right? Elephant and all. I think I forgot about the big five. They're together, and then there is domestic animals, cats, dogs, right? And then there is the insects, which are grouped together, right? So when you pass a lion, it will go. It will inside that embedding space, it will be able to go to the group of the big five. Now inside the big five, it will now they get the best one that is close to a lion there, right? And then it will be directed to the large language models. So things similar to each other are grouped in the same group, and then the best group, once that group is selected, now the best output will be taken out. So this is best for systems or use cases that you want that are going to be scalable. There's another one called brute force, but brute force you're going one by one by one, and brute force in any scenario, even in algorithms, are not recommended for systems that you want to be scalable, right? So approximate nearest neighbors are fast, scalable to larger data set, slightly reduced recall time, right? Now, this was the explain I was trying to explain. So the index to form similar groups. These embeddings are indexed to form similar groups. So when a user performs a vector search, the embedding input is first checked against the closest group. It's then compared against all the embeddings in that group to find the most similar text. This approach is significantly faster, scalable, and has impressive recall. Now, embedding space, right? So position of objects within a vector space captures the meaning, right? This extends to the multimodal. So for example, the size, the color, and the living, right? They are closer to each other since the cat is laying in front of a tree. So this embedding space has been now improved to even work with an image. So you have an image that this image maybe contains someone that is next to an airplane. For example, when the DCI wants to find people who occupy JKIA, so the people who have a background of an airport or a background of a plane or a background of them boarding a plane, right? They are more closer to being criminals than the ones who are next to KICC or something, right? So this embedding space are really uh, help to group things that are similar to each other. Now, it contains three things. Transformation. It's a concept where complex objects like text, image, or audio are transformed into numerical vector space. So there's what we call dimension reduction. This new space usually has fewer dimensions than the original data, making it easier for algorithms to process and analyze. So it has fewer dimensions than original data, so making it easier for the algorithm to process and analyze. Then similarity preservation. Similar objects in the original data remain closer together in the embedding. For example, words with similar meaning without would have nearby vectors. Now, to summarize what I've just spoken about, embeddings and a vector space, embeddings and a vector search, these just help in the retrieval part of a RAG, right? You're trying to retrieve something, right? So chunks retrieved from a vector search are fed into LLMs. And then now the augmentation and the generation comes after you have retrieved your chunks of data. So this augments the existing LLM's knowledge with information it wasn't trained on, right? Then the LLM generates a response that weaves together retrieved chunks plus the pre-trained model, the pre-trained knowledge, right? Now, let's understand now the remaining two parts, whereby the augmentation and the generation. This is a simple standalone LLM where we started, right? whereby you ask, what does this warning light mean on my car? And this car is the newly released car, right? So it will generate a response and give you an answer that is general and doesn't give you the main context that you want to work with, right? And you're working with a use case about a car, and also we thought about another use case in our discussion about a HR bot in your organization, right? So now RAGs comes in whereby you have the question, right? The question passed into an embedding. It's converted into an embedding, right? And then this embedding it's placed in an embedding space, right? Whereby a vector search is conducted, right? When a vector search is conducted, and you get the best and the top relevant items. Now, what we need to know is these embeddings are not stored in our normal databases, right? For example, you cannot store embeddings in normal MySQL database or Firebase, right? These embeddings are stored in what we call vector databases. These vector databases or vector stores are able to store embeddings and can be able to conduct a vector search through it, right? An example of a vector database is what we call ChromaDB, right? Chroma, I mean it. So there's ChromaDB, there's OpenSearch, there's LaunchDB, and then a good database that supports that has a vector database support that and also has the capability of vector search is Postgres, right? So all this, once it goes to a vector database, we fetch the actual chunks document, the chunks retrieved, and then we get the relevant top K relevant items. So top K is just a probability parameter that enables you to get the topmost or the best one, right? For example, you have a statement that has you have two words that are similar to each other, and you want to get the best one that is relevant to the query that has been passed through, right? So the best one is given and it's passed through the LLM to get a better answer. Now we have gone through the principles of RAG. We have understand what a RAG is. Now we want to know about what we call multimodal RAG patterns, right? The patterns of multimodality, right? How the image, text, code, right? Now, documents can contain both text, image, code, and audio. Not audio, code, right? So when this document is passed through an embedding models, these embedding models, they're both text embedding models, image embedding models, right? So, and they are multimodal embedding models, right? So when it's a text, it goes through a text embedding model, summarizes the image, right? And then it goes to a vector database and then retrieve with text embeddings, right? So traditionally, before the multimodal embedding were brought about, people used to use the text embedding, right? Whereby when an image is passed, it summarizes the image and gets the text out of it. And then using this text, you can get the relevant thing that you want, right? But now with the multimodal embedding, with the same image, you can compare it with another image, or with the same code, you can compare it with another code and get an answer. So with a multimodal embedding, you can pass through an image and compare it with another image, goes to a vector database and retrieve with multimodal embedding, summarized with multimodal large language models. So today's context, so we purchased a new car, the 2024 symbol Starlight, and we want to ask questions about it, right? So this is just a simple use case that Google created, right? Just to show an example of RAG. So you pass. I've used the you have the model name, which is the Gemini 1.5 Pro latest. And then you pass a response. How many miles can I drive the 2024 Starlight before I need to change my oil? Right. And then output chunk tells you, unfortunately, there's no information available about a vehicle called the symbol Starlight. Perhaps you're thinking of a different model. If you can provide a deeper meaning about it. Another example you can say, maybe you pass, tell me about, for example, now someone works at Google, right? And Google wants to create a HR bot. You can say, tell me about the vacation policy of Google. Or tell me about the benefits, right? The medical benefits, medical insurance benefits that Google does actually get, right? Uh, Gemini doesn't know more about it since it's proprietary information. Now it will tell you it doesn't have that information. So using we have a context now, right? And this is an example of a context, and another good example of a real world use case context is a HR bot, right? So we have the 24 symbol starting manual. Let's use it to argument the Gemini LLM and give us a better response, right? Now up to there, I will take the first part of the session questions before I jump into a short demo.
Thank you for that, Farah. I see people are really commenting on the examples that you used. It was really insightful. So the first question you have is it the case that LLMs hallucinate because of the data they've been trained on, and RAG is used to generate a more balanced model?
Good question. Interesting question. Now, it's not the case whereby it's about the data the LLM has been trained on, because since these LLMs are trained on just pure general data, right? But when you have RAG is used to help you, it's used to give you context, right? So you have a use case, a specific use case, right? And for example, and you have a knowledge base, right? That this LLMs doesn't have access to. So RAG simply helps you to give you a better understanding, right? Or your internal data source, or internal knowledge base, right? Since, for example, I've given you an example of an organization like Google, right? Gemini hasn't been trained about deep details about how Google maybe benefits work. When you go into a company, their benefits, their vacation policies, doesn't have, right? But if you want to have an internal HR bot, right, you are able to give it a context, which is your data source, right? And then combined with the pre-trained knowledge about the general policies that are out there, it will give you even powerful meaning. Hopefully, I answered Ian's question.
I believe so. But then there's also another question there on when it comes to scalability when dealing with multimodal inputs and outputs. What are
Yeah.
the computational challenges and like the optimizations involved?
Yeah, good question. Good question. So that's why I mentioned about brute force, right? Since there are different types of uh, uh, vector search that you actually conduct, right? So if you want your systems to be more scalable, when you use that the example I gave you about the approximate nearest neighbor, it's more capable to adopt uh, systems, and can be able to handle computation, and optimization is even better. But when you do brute force method of vector search, whereby it goes through every single embedding to find the one which is similar, right? You see, there's a limitation there, right? It depends with the actual approach you actually aim for, right? That's why I gave you the best approach is approximate nearest neighbor, which is scalable and optimizable, and can handle large amounts of data set.
I think the last question we had was when it comes to like a real world situation dealing with multimodal drugs, how do they compare with the traditional unimodal approaches?
So I can give you an example. The unimodal or the single one that worked with text is now there's the limitation of now computation, right? Since the unimodal they use the way that they used to work is even if you give it an image, right? When you give it an image, it uses text. Once it uses text, it extracts the text details and it uses the text details from the image or the description of the image to give you an answer, right? But now you have multimodal whereby if you have an audio, if you have an image, if you have a code, it compares that with another one, right? Which saves more time and actually gives you a better answer and more accuracy.
I guess that answers the question. I don't believe we have any more on the chat so far.
Okay, so I'm gonna share my screen on the demo I wanted to show. Minutes. Can you be able to see my screen yet?
Just the slides.
Oh, let me. What about now?
Yes, you can.
You can? Okay, okay. So I'm gonna be using what we call LangChain, and I'm gonna take 1 minute to explain what LangChain actually is. And I did a slide on that, a short slide on LangChain. 1 minute. Okay. Let me share my screen. So this is just an addition to what we actually went through. Now, LangChain is something that is really, really important in RAG developing RAG application. So I'm gonna go through it just a short while, and then we jump into just a short demo. But I'm gonna also share the resources. So it's a simple open source orchestration framework for the development of application using LLMs. So it serves as a generic interface for nearly any LLM, providing a centralized development environment to build application and integrate them with external data sources and software workflows. So in simple terms, LangChain makes your RAG application development easier, right? Now, how does it work? So it at its core is a development environment that streamlines the programming of LLM application, right? Through the use of abstraction. So, meaning it simplifies how you code by representing one or more complex processes as a named component. So what you could have done using a like 20 or 50 lines of code, you do it like with 10 lines of code, right? So something that could have been doing, you could have coded like many lines. You just import a simple a simple import, and then you can be able to work with it. So what are the components of LangChain? So the first one is importing models. So nearly any LLM can be used in LangChain, right? So any LLM that you know, for from Gemini to GPT to Anthropic to Watson X, all of them, LangChain has support for it. So importing the models is easier. Second, prompting template. So what we need to know in working with LLMs is prompting, right? And this is where maybe, for example, when you let me take an example of us of students or someone who wants, when you want to go and ask a question, sometimes we go wrong on how we ask the LLMs, whereby we tell them something and it gives us something different from what you actually wanted. But maybe the problem came about where we didn't actually know the art of prompting or telling the model what you actually want. So prompting are instruction given to the LLM. It's an art of composing prompts that effectively provide the context necessary for the LLM to interpret your input, right, and structure and output in the way most useful to you, right? So what does it help with, right? Creating a prompting template class, right? For example, whereby you have a template whereby you can be able to work with. You don't need to create your own template, your own prompting method. There's a template where you work with, right? So it makes your prompting ways easier. Another component is chains. So chains are the core of LangChain workflows. So they combine LLMs with other components, creating applications by executing a sequence of function. So you want to tell this LLM, so you start from here, then you go from here, then you do this and this. So there are chains, a sequence of things. So I want when you start from here, you go to the next one and one. So you tell the LLM, when you go to this function, don't go to the other function, go to this function and then come back to this other function. So when you, for example, you have a different types of data sources. You have a sales data source in a different database and a something data source in a different place. So you tell, go to this one first and get this, and then after that you get the other one, right? So that's the what changes. And then another one is indexes, right? To achieve certain tasks, LLMs will need access to specific external data sources, not including in its training dataset, such as internal documents, emails, or dataset. So one thing is the document loaders, right? Instead of you going to get your documents and loading it yourself, there's a document loader that allows you for easy importation of data from its sources. Vector database. Instead of you going to find databases, it gives you an access to a vector database. Another one, text splitters. So text splitters split text up into small, semantically meaningful chunks that can be combined using methods and parameters of your choosing. And then the last one, the retrieval part, which we spoke about. Another one, memory. This one is also key, whereby, for example, when you use Gemini, when you ask something and you want to continue with a follow-up question, Gemini has it. So you want your application also to have it. You want your HR bot to actually have it, the use case you're working on. So your HR bot, you ask it, what vacation, tell me about the vacation policy. And then down there you continue. As a junior developer, how many vacation days am I eligible to go with? Or you continue. if I do this with my vacation, so it stores memory, conversational history of your chat. And then agents. So LangChain agents can use a given language model as a reasoning engine to determine which action to take. When building a chain for an agent, inputs include a list of available tools to be leveraged, user inputs, any relevant previously executed steps. And then, yeah. So as I finish up, I think I'll finish up with just a simple, uh, um, not kind of demo, since why I couldn't be able to do a demo is, first of all, I don't have the capacity to afford the resource allocation of working with these Gemini models, right? So when I pass through a large sample of data, I have to pay to use these APIs. So I went to the resource that I was working with, and maybe I can go through the code in a short while. So this is just importing the libraries, right? So LangChain again, right? So importing the prompt template, the vector retriever, and the memory store. That's why I wanted us to go through LangChain a bit to understand what it is. So we're going to use Chroma, right? And then some data loaders, some runnables, right? Now we will define a model here, which you're going to use Gemini 1.5 Flash, text embedding model also, and the token limit. And then we're going to load the data, just uh, a simple image data. Now we're going to we extract images, tables, and chunks from this PDF file. So we extract it, right? And then we categorize extracted elements from a PDF into tables and text. Then after that, we can be able to get summaries of the text elements, right? So we give it a prompting text here. So we tell it you're an assistant task within this, right? This summary will be embedded and used to retrieve the raw text or tables. So give a concise summary, right? So we create a chain. This is what I meant by a chain. So you receive a prompt, it goes through a model, and then you get an output. Right? So initialize empty summaries and then apply to text if texts are provided and summarization is actually required. And then we encode these images, and then we actually get the the summaries. Now I want to go to this place whereby, yeah, you tell the assistant summarizing the image for retrieval, and then you pass the model name, and then you have the token limit, and then we get the image summaries. Now remember, here we just have the summaries of the images. We haven't passed it through a vector. We stored it in a vector in a vector database. So once we have the summaries, we place it in a vector database, and then once it's in a vector database, we conduct a vector search, and then we get the best one, and then we pass it out. So due to the time constraint, because I see my time is almost up, I'm going to share this link with you guys so you can go through it. Should I share in the chat, Ethan?
Yes, you can. You can just share it in the chat and I'll forward it to the other chat.
Okay, let me share it with you. I've shared it with you. You can forward it to them. So yeah, I think I'm gonna end it at there due to time. But yeah, I'll take questions now. Is there any question?
I can't see any so far in the chat, but I just wanted to ask. So how are
Yeah.
you see the language? The agents are like the language chain agents. How are they trained and optimized to understand and generate natural language responses?
Which ones? Agents in LangChain or very
In
specifically?
LangChain, yeah.
Yeah.
In LangChain, yeah.
So agents is just in simple terms, they're just you can be able to make it like a reasoning engine, right? So you want to tell this model which actions to take, right? So what to do. For example, you're giving it instructions. You're telling it, uh, my organization is like this, and sometimes if it goes this, don't go this way. This is the way to go, right? So it might contain maybe steps, executable steps, and also sometimes it contains prompts, and also maybe sometimes it contains tools to be able to guide the models.
But then how do you ensure they adapt to the user preferences?
Yeah.
How do you ensure they adapt to the user preferences?
So these agents continue to learn, right? They are able to take in every user query. They'll be able to learn the patterns of the queries, the patterns of the execution that actually goes on in your application, right? For example, you see this is the most common ways people execute. This is the most common queries, right? They'll be able to learn and adapt. So they give more power when you want a better output. So this one can be able to, through the chains, pass through an LLM and get an output.
Okay, I understand now. I
Hmm.
don't. I thought there was a question on the chat, but I don't think there's any further questions. What's left for me is just to thank you for your time and also to thank the audience for joining us. And past that, I hope we can meet again tomorrow at 6 p.m. for the cloud sessions. If anyone has any questions in regards to this, I think they can just text you on what's it called, on LinkedIn. They can just find you on LinkedIn or on Twitter.
Yeah,
Like you
let
need
me
to
share let me share my LinkedIn right now before we leave, for those who want to actually. I forgot to place my. I'm usually not that guy who actually puts links. I forget, you know. So you can share with them my LinkedIn. So if anyone wants to contact me, there's my LinkedIn. Yeah.
Thank you for that, and have a good evening to everyone else.
Yeah. Have a good evening. Bye, everyone. Thank you.
Cheers.